This is our pre-calculus lesson on dot products of two vectors. Dot product is a number, a scalar. Now, it doesn't have a whole lot of relevance to regular life. It's used specifically to find other things. So as a number itself, it isn't a whole lot of meaning. It's what other things we're looking for. It's used to help with two different topics, and one of those topics is to find the angle between two vectors. So if I happen to have two vectors, one of them vector v and one of them vector w, and I want to find the angle between, it would be very helpful to find the dot product, and we'll see that we have a formula that uses the dot product in it. So it's a number that we would need for the formula to find this angle out. The second topic that has relevance with dot product is that of work, which is a physics concept, and it's very specific to two types of vectors. But it is taking these very specific types of vectors, and we find the amount of what's called work that's done in a situation by using the dot product. So let's first look at how we compute the dot product. So to compute the dot product, there's more than one way, and the first way is by looking at the components of the two vectors. So if I have one vector and I call it vector v, and it has two components, the a and the b, the horizontal and the vertical component. So I'm going to say the a sub v and b sub v for vector v. And I have a second vector, vector w, and it has its two components, a sub w and b sub w. To find the dot product of these two vectors, I'm going to multiply their a's together. I'm going to multiply their b's together, their horizontal component. I'm going to multiply their vertical component, and then I'm going to add those two products. And so this is how we write that equation. We say the dot product. Now, this little symbol is a larger dot. It's not a small dot like we use for multiplication. It's larger than that. And this says the dot product of vector v and vector w is the a's multiplied plus the b's multiplied, the horizontal and the vertical parts of the components. So here's an example, just a quick, let's put it into practice. We have components for vector v and vector w, and there they are. I'll leave the formula right above it. And so we can see that what we're going to do is we're going to multiply our two a's, so -3 and 2, we're going to multiply those. And then we're going to multiply our b's, our second component, part of the component, 5 and 7. We're going to multiply those, and then we're going to add those together. So we've got -3 times 2 is -6, and 5 times 7 is 35. And so we've got our equation that is -6 plus 35, and we get a grand total of 29. And that is the dot product of v and w. So we're going to use this in an example in a little bit. So using the same two vectors. So this is how we find the dot product. Now, we said that there were two different things that we use it for, and one of them is to find the angle between two vectors. Well, to find the angle between two vectors relies on us to use a theorem about dot product. And the theorem is that the dot product can be found by multiplying the magnitudes. That's a multiplication dot. So multiply their magnitudes and then multiply that times the cosine. And so, wait a minute, I thought this was multiplying my a's and multiplying my b's and then adding together. It is. That's one way to compute the dot product, but we're also saying that the dot product can be computed by doing this, by multiplying their magnitudes and multiplying that times the cosine of the angle between. And it's a theorem we have about dot products. If we use this theorem and solve it for theta, so what we would do is we would divide both sides by this product of the magnitudes, and then take the arc cosine of both sides, we end up with this equation. You say, oh, to find the angle between any two vectors, we take the arc cosine or the inverse cosine of the dot product divided by the product of the magnitudes. And so that's how we use the dot product to help us find the angle between two vectors. The next concept is that we see, if you've taken any physics classes, or you will in the future, you'll have a concept called work. We want to know this work. And maybe you've heard things in units of joules or in foot-pounds, that's usually something called work. It's the amount of work that was done, some action that was done. So specifically, when the two vectors are, and we have these two different types, a force vector that's acting on some object. So there's some sort of force, some pull or push that's happening to an object in a particular direction. That's what makes it a vector, that it has magnitude and direction. So we have this force vector, and we have the displacement vector, and that is that the object on which this force was being applied has been moved, and it's moved some magnitude, some distance. The distance would be its magnitude, and in a particular direction. And from that previous formula that I just showed you, we say that we've got the dot product, so the work is considered the dot product, and that's also that since we know from this other formula that we had here, the dot product, that's the product of the magnitudes of cosine of theta, we could do work in that way as well. Because most often we don't have the components for these two things. It's an action in the real world, and we don't have the components for the vectors. We have their magnitudes and direction. So oftentimes you're given their magnitudes and the angle between them, so you would use this formula. Okay, so while we do say that the dot product is work, this is typically the way we're going to compute to find work. So let's look at an example that has to do with work. And in that example, we have a crate, and it's going up an incline, a 45-degree incline, and it is moved up that incline 600 feet. So this is the displacement vector, that it was moved 600 feet at a 45-degree angle. So we've got its magnitude, and we have this angle, and that's actually the angle between the way the crate is moving and what is making it happen. So there's some kind of a machine or something that is pushing or pulling this crate, and it is using a force of 1,000 pounds, which again is a magnitude. This 45 degrees is the angle between these two vectors acting on it. So the magnitude of the force is 1,000, the magnitude of the displacement is 600. Of course, these are pounds and these are feet. And this is kind of a diagram of what's happening. Right here would be the crate. The crate is going up this incline 600 feet, and then it's stopping. What's creating that to happen is a force is constantly pulling this or pushing this object going across this way, which is why there's an angle of 45 degrees between them. So using that theorem, and we know that it's the dot product, we know that work is the dot product, but we don't have the components, so we're going to use this formula for the dot product. We're going to multiply those two magnitudes, and we're going to multiply it times cosine of 45 degrees. So you'd use a calculator, and we're going to round to the nearest whole unit. So we're not going to have any decimals in our final answer here because it's a rather large number anyway. And the answer to that is 424,264 foot-pounds, and that is work. Let's look at one more example. And this time, in example 3, we're going to find the angle between two vectors. Which two vectors? Well, the ones we used before, vectors v and w. So we're going to find the angle between two vectors, and we're going to round that angle to the nearest 0.1 degree. We have these two vectors from earlier, vector v and vector w, which we already computed the dot product for. If you'll recall, when we did that before, we got the dot product was 29. And we have this formula that says, oh, the angle between those two vectors is the arc cosine of the dot product divided by the product of their magnitudes. So we have our dot product, which was 29 that we did before. We find the magnitude of vector v. We find the magnitude of vector w. We're going to multiply these two magnitudes together, and we have this. Now I have all these decimal digits in my calculator. Leave them in your calculator because you want to use the whole thing. If you truncate, if you round, then you're going to end up with some errors in the problem, or that you won't come as close to the actual answer. So now we're going to use the formula that says the angle is the inverse cosine of the dot product divided by the product of their magnitudes. We plug this into our calculator and we round it to 1 decimal place and we get 46.9 degrees. And that's finding the angle between two vectors.